Hello and welcome to this talk on interactive and interpretable online human activity recognition. My name is Jarle Hartmann and I've written this paper together with Hui Liu and Tanja Schulz. In this live demo of human activity recognition, we will do three things. We will do data collection, which I will showcase in a bit, which is combined with adding new activities and retraining the hidden markov model that we use for recognition in the background. So typically I would give you a sensor and tell you to do an activity, press a button, etc. And then we will collect the data in the background, retrain, and use this in the core of the demo, which is live visualization of how, why, and what aspects of the hidden markov model make the decision in order to predict the activity that you're actually performing. For the setup, we will be using a IMU, so an inertial measurement unit, which we will be focusing on the accelerometer and gyroscope for this particular instance. All of the data of all the other sensors, so magnetometer, temperature, etc., are also recorded, but neither visualized nor used for the recognition that we will do in a second. All of the things that I show you right now are technically customizable. I will skip through most of that for the meantime. If we have time later on in the question section or the parts, I will be happy to demonstrate that. For the moment, we can see here, this is live data from the arm, which is also plotted here in this case. So what we will do now is not only receive live data from this IMU and plot it, but we will also add two more and quite important steps. First of all, we will also add the ability to annotate the data with a UI button in this instance. Technically, you could also use any other annotation mechanism that you'd like a physical push button or annotation other instances. The data will then be stored. This is the out data node. And we will also use it to update a model in the background and on the fly. So that means that we have, if there's a new activity detected, we will assume it has 5 phases, and we'll then try to train that one in the background. Right. So what we see on the left-hand side in this plot is again the live data, which we'll usually want to have in order to see if the sensors are connected correctly in such sessions. And then in the middle you have 2 text boxes and a button, where the upper one is basically whenever you don't do something, this is the fallback, so this will be none as an activity. And then we will do an activity which will consist of pausing shortly, moving the arm to the left, pausing shortly, and moving the arm back into the middle, pausing again. So that's where these 5 phases also come from. So this matches up in how we configured it earlier and how we'll record data here. So basically press start, do the activity, press stop. We can do that a couple of times, and as you see on the back on the right hand side, periodically, so in this instance we set it to every 60 seconds, based on the data that is seen there and or maybe data a model that is already existing. We update this model, and if there is a new activity, we add it with these default parameters. If the activity was already known, the different parameters are updated based on the newly seen data. At this point, I would like to do a short refresher on hidden markov models. So I want to think of hidden markov models basically as a search graph comprised of these different activities, which we traverse by scoring observed frames with Gaussian mixture models. So that is to say that we update our best hypothesis of the activity phase that we think we're currently in, based on each newly observed frame, and as well based on our previous hypothesis. So we basically pass a token forward, if you want to think of it. So think of it as, for instance, if we were in this initial state of walk initially, and we see a new frame, we figure out, okay, how well does it fit that we are still in this state based on our Gaussian mixture models, as well as in this frame, or that we traverse into this next state based on the Gaussian mixture models there, etc., etc. So with the data collection for this demo and the refresher on hidden markov models out of the way, we will come to the core of the demo, where we will have several plots that display what the hidden markov model thinks, where it is, what it's seeing, and how it's going along. So we will have live input from the sensor that I've just showed you into a recognizer, which will then give us insight into which Gaussian mixtures it thinks it currently are most likely to recognize, as well as where in the search graph or which state in the phases it's thinking to currently be in. So you see on the upper left-hand corner, you see again the raw data plot, and on in the lower three bottoms, you see the accelerometer plotted against the gyroscope. So you see rotation along one axis plotted against movement along this axis. So you can see basically if I'm moving my arm up and down or left or rotating it, you can see that in the x-axis most of the time. On the upper right hand side, you see the search graph, or the most likely current state or phase it's in. We could show more than one here, but for the sake of the demo right now, we opted to show the most likely one. So currently, the system thinks that we're at the end of the left movement. If I lower my arm like that, it thinks we're none. So if I go left now and go back again, you can see how in the search graph it moves along based on that. So if in a second I will try to move to the right and stay there, or to the left, sorry, and stay there for a short time, you can see also how this remains in the search graph at that state as the most likely explanation, which is also what you see in the data on the lower hand, how that matches quite well to the Gaussian mixture models that were learned there. And in the middle plot, you can see basically along the time axis as well, which different phases basically were seen and which activities were seen. So we have four different plots there basically. The lowest one is currently inactive because we have live data, so we don't have a reference. The token is the activity level, so we have left or none as options there. And then on the atom level, we basically have these are the phases. So you can see there's also the same gradient approach that you have in the search graph over there. And then subphases of that typically in spoken or speech recognition, but not as applicable here for now. But you can see basically the same explanation pattern going on there. So we see the same plot here again. I've gone ahead and collected one additional minute of training data for a right movement, which is basically the same movement as left, but starting with going right and then going back into the center again. So it has the same idea of 5 phases, but as you might intuitively already understand, is there is definitely overlap here. So we can see that the system kind of recognized them correctly, but also has some problems there and kind of sometimes switches between left and right after the initial pause. So that's also one of those interaction things that I talked about, which are interesting if you want to consider and figure out what your system does and why it does things that it does. This concludes my demonstration on our demonstration paper, Interactive and Interpretable Online Human Activity Recognition. Our main contributions that we showed here and have here, which, like I said again, I would rather have you give you the sensor in hand and have you tried it yourself, but due to restrictions, we have to do it this way. We showcased and demonstrated an interactive human activity recognition live demo, where you can have data collection with the audience or with students, or even with people of the general public that you want to record data with. You have a plug-and-play functionality where you can add new activities which are on the fly learned in the background, based on the models based on the data that you've just recorded, and then also directly stored, so you can use it in a session directly afterwards. And the core contribution of this particular demonstration and this particular part is the live visualization and way to interact with how the hidden markov model actually does the recognition and how it comes to the conclusion that it comes to. And with that, I'm open for questions, and I'm very happy to also show you this demonstration live if time permits, or we meet in some other location.